All right, so back to playing with standard deviations. We're going to play around with what standard deviation means, how we calculate it, this 95% rule for identifying outliers. And we're going to do that with the all countries data set from the book, which you may have your own copy of already that you downloaded from the book's website or from my Google Drive with these. If not, I'm going to share it. And remember, when we share a Google thing, we want to make sure that the get link is set to anyone with the link can view it if we want to share it with each other, like your teacher for a grade or someone in the class. Oops, I forgot to hit copy there. So for those of you looking at this in the future, there should be a link to this in the description of the video. Otherwise, oops, I sent it to the wrong group. Again, you should see a link to this in the chat. And if you have your Google Drive open and you open this a previous day in class, it's probably in your recent files. I see a bunch of people jumping in there. Okay, let's see. What did I want to look at here? I believe I wanted to look at, okay, birth rate, death rate, and life expectancy. And I teach a couple versions of statistics. So I had played with other classes with this earlier. So I have some pre-done histograms, but I'm just going to start over here. So I'm going to make, just start from the beginning. I'm going to grab the country name because I like to have those references. I'm going to copy that into a new one. And I think I will do birth rate next. I'm just going to call it sheet 4 for now. With sheets, you can't have two sheets with exactly the same name. The computer doesn't like that. And then I want the birth rate. Scrolling over, birth rate. And anytime you have a data set, it's always not clear by the title in the summary what that means. So sometimes, somewhere you got to find a key for that. And so there is a key to these in the back of the book. Birth rate is usually percent. Let's just double check. Look in the back of my book. Data set descriptions, all countries. Birth rate. Oh, this is births per 1,000 people. Okay. So put that in here. Births per 1,000. All right, so I'm in my sheet 4 here, so you could either do the same on your version of this, or just take a look at what I'm doing, or make a copy and play around. So let's see, I guess I'm gonna get the summary statistics I need. In that previous spreadsheet, when we were playing with all students' height, when I made these calculations, they were just based on the column that was 1, 2 to the left of where the calculation is, and I grabbed the whole column. So I should just be able to highlight all of these from the average student, Control C, come over to this spreadsheet. As long as it's in the same position, vertically and horizontally, it should work correctly and make those calculations. So one cool thing about spreadsheets and the calculations we make, it's possible to make these reusable calculations, which really saves a lot of time. If that wasn't in the possibility for things for you to do today, I'm just going to repeat those from the beginning. After this example, I'm going to do it quickly so we can move on. But count is just counts. And in this case, it is safe to just click on the top there. Mean is average, just plain old average, not any of the other ones. Thank you. Standard deviation, STDEVS for sample is the one we want there. It's very important you get the right one, otherwise you won't get the same number. Oops. Let me change the view. Should be okay. And then for the quartiles here, I do have kind of a cute, quick way to do this that I'll show later maybe, but I'm just going to use what I did last time. Minimum of the data equals equals quartile inclusive. Oops, wrong one. Sometimes my mouse hand doesn't click right. The only one in the world. What did I do wrong there? Oh, I forgot to tell it which quartile I want, comma, I want the first one. Data. So remember, some of these commands need more than one piece of information. So the quartile command, quartile inclusive, exclusive, or quartile needs to know the data and which quartile you want. 3, and max is just max. So those are my summary statistics. We'll come back to this particular one and look at those guys there. I had already rounded these, so if yours weren't rounded, like these came out to long decimals, you just want to decrease until you have 2 decimals. And the rule is not 2 decimals, it's 1 more than the data. So in my data, I see 1 decimal point in these measurements. So in my statistics, and remember, statistic is just a calculation based on a data set, sample, they should go to 2 decimal places. My median quartile already went to 2, so that's good enough. All right, so we have, the mean is about 20 and the standard deviation is about 10. Those are nice numbers, they worked out good. So next thing we want to do is we want to get a histogram to explore the 95% rule. So highlight the data, quick histogram. Are we going to get a histogram today? Yeah, nice. And what I'm going to do is I'm just going to choose 10 to be the spread. What did they, that might be too much. I might need to do 5. They picked about 3 here for their bucket size, bin size. So customize histogram, I'm just going to play for a second. They picked about 3, so that should look pretty similar. Yeah. 5, which is half of my standard deviation. It's not bad, but I think 10 is going to be too few columns. Yeah, that's not very good. So let's go with 5 then. And so I'm choosing 5 for a couple of reasons. One, it's about half of the standard deviation. Sometimes I make a histogram based on the standard deviation, but 10 didn't work so well. And 5 looks pretty good. So starting at 5, 5 to like 9.9, and then 10 to 14.9, 15 to 19.9 is what's being counted in each of these groups. Better title here, birth rates of all countries is good. There we go. Birth rates, birth per 100,000 per 1,000 people, that's good. And then this should get a name too. And what are we counting here? These are technically called frequencies, but frequency is not a very good name. So I think I like to call this number of countries. I'm counting countries, specific birth rates. All right, nice. And so then on a piece of paper, I would, if I were you, label 5, 10, 15, 20, and so on, and just make a rough sketch of these columns. They don't have to be perfect. I have the digital gift of making a screenshot. Page, please. I just got my pages out of order. Fix that. All right, so make a rough sketch on a piece of paper of this, and then we're going to use the mean and the standard deviation. So I'm just going to write them down here. My mean, X bar, was approximately 20. And whenever I round something, I use a wavy equal sign. And my standard deviation, S, I'm going to say that's approximately 10. Just for fun, I'm going to reference the median. Would you guys agree that this is skewed right? There's definitely a right tail compared to the bulk of data here on the left. The skew is always to the tail. Right? That's where weird stuff's happening. I wonder, like, ooh, why do these ones have such high birth rates? Interesting. What was my median? I have that here. 17.85. So it's just a little bit less. The mean is a little bit greater, and that's reasonable here since there's a skew to the right. Do I got my right with my right hand? Yep. that right data floating out there is pulling the mean away from the median. So there might be some outliers here, some countries who have unusually high birth rates compared to the rest of the world. Okay, so I'm just going to mark my mean here. So right here, that's my X bar, and then I'm going to start counting by the standard deviation. And sometimes I just make a whole new axis underneath for that count. And so right down here, that would be 0. And when we count by the standard deviation, that's called a z-score. So I'm going to label this axis here z, and just a note to myself that I am counting by the STD. So 10, so 5, 10. So this right here would be 1 standard deviation to the right. So I would label that as a z-score of 1, and then 5, 10, 40 would be about 2 standard deviations to the right. So that would be about 2, and then 50 way over here would be about 3 standard deviations to the right. So whenever we count by standard deviations, that's called a z-score. Going the other way, from the mean, if I subtract 10, that puts me right here at 10. That would be a -1. And then subtracting 10 again would take me off the chart over here about 0. That would be -2 standard deviations. And -3 standard deviations is at -10, which is like, you can't have a negative birth rate. And if a country has a 0 birth rate, then that's troubling too. So way over here, so this is a 0 birth rate. This is a birth rate of -10. That would have a z-score of -3. These don't exist, right? You can't have a birth rate below 0. And I want to check out the 95% rule here. So the 95% rule that says if you look 2 standard deviations on each side of the mean, so here I am at 2 standard deviations to the left, here I am at 2 standard deviations to the right, I should expect to see, oops, about 95% of the data in there. There are no unusually low countries, but it looks like there are some countries with unusually high birth rates. So these over here are outliers. According to this rule, there's many others, it turns out, and they are unusually high birth rates. So let's just double check that 95% by looking at the data. Now, in order to get this number here, I'm saying is about 40, 2 standard deviations to the right, I'm taking my mean and I'm adding to that 2 standard deviations. So I'm going to make that calculation in the spreadsheet to confirm it's 40. Now I'm just guessing it's 40 by my approximations there. To get this position right here, I'm going to just draw a line in the sand here, right? That would be take your mean and subtract 2 standard deviations. So, and we should find that's it's about 0. So let's just double check that on the spreadsheet and then count how many numbers, how many of our countries live in this region right here that we've marked off. So I'm going to add a new place. Let's go way down here, say, and I'm going to call this the mean, let's go -2s, and then we'll calculate the mean plus 2s. So anytime you make a calculation in the spreadsheet, it's a good idea to have a label explaining what you're doing as briefly as possible so that when you look back at it later, you're like, what the heck was I doing there? All right, so to make this calculation in a spreadsheet to calculate, you type in equals, and then we just click on our mean. The dash hyphen is a minus 2 times, and on a spreadsheet, you have to put the asterisk in to multiply. You can't just put 2 things next to each other like in algebra. So then I go -2 times standard deviation, enter. So that's pretty close to 0. 0.16 compared to like 38 or 35. And then to get that other line we drew, that would be the mean. So equals, click on the mean, and then plus 2 times, and then click on the standard deviation. Okay, so that one's about 40. So my estimates were pretty darn close. So next thing I want to do is count. Okay, how many of these numbers are between 0.16-ish and 40, so roughly between 0 and 40. To do that, I need the numbers in order, and I have not sorted them yet. The quick way to highlight a whole group of numbers, Control Shift and then down arrow will look for the bottom of the list. Oh, interesting, we have a bunch of blank ones. Oops. I messed that up. Try it again. If I go to the bottom, Control Shift up arrow, and then Shift right arrow will highlight just those two columns. So the keys can be pretty helpful, quicker than the mouse sometimes. But I just want column A and column B highlighted, and then sort them. I want data, sort range, not the first four options, but this fifth one. It does have a header row. I don't want it sorted by country. I want it sorted by birth rate. Smallest, largest, sure. And it'll put all the blanks at the bottom, like get them out of the way. All right, so the smallest one is 7. That's definitely above 0. And I'm looking to go up to 40. So I just kind of highlight, scroll down, looking for that 40. Okay, so it looks like 39. And then in the bottom right corner, I'm going to switch from sum to count because I want to know how many there are. Okay, so I counted 194 of them. And then I have to look to see how many there are. So scroll back up. Another note to myself right here. Within STDs, I have, oh shit, I forgot. Was it 139? I gotta do it again. Oh, it's putting in the formula. I totally messed this up. Anybody remember? What do I have there? For now, out of, you guys have memories like me today, 202. Whoa, 68%. Oh, I must have messed that up. Okay, I gotta try again. So I think what I'll do is just, I'll go equals count right here. And I'll just highlight the ones I want to count. Or should be just those. Oh, it's 194. Man, was I off. All right, and then I want to divide that count by the total number, which was what, 202. Okay, and we get about 96% in this case, which is close to 95%. So I'm just double checking. Hey,
wasn't it 93? Or 203, sorry.
202 was the sample size. And now there are more countries than that, but I'm only looking at the countries that actually provided a birth rate or which we could find the birth rate for. And I got 202 of those. Oh, I see where you're getting the 203 from. Yeah, so one thing we want to be careful about when we're counting is not to use the row number as a count. So although this last one is in the 203rd row, the first row of the data tells what the data is, right? Country versus birth rate. So there's actually only 202. All right, so yeah, it's about 95%. And then I can then identify in my list here the outliers. So if we go down to the bottom of the list, this group right here, let's highlight those. These are outliers. More specifically, they are unusually high compared to the rest. So these countries, there we go, unusually high birth rates compared to the rest of the countries.
Those are in Africa, so that's interesting.
The high birth rate
population is higher?
No, yeah, that is interesting, isn't it? Yeah. Huh. Yeah, so then it's often interesting to say, okay, why these countries? Why are they in Africa? What's going on here? All right, so again, they're outliers. More specifically, they're high compared to the rest, according to the 95% rule. And the 95% rule just says, hey, mark 2 standard deviations on each side. All right, so let's get back to this, talk a little bit more about it, and we'll do another data set, and then we'll talk about percentiles. So just some observations about this data set based on the statistics I have so far. So birth rates. So yeah, that's a good point in the chat. It's not uncommon for countries with greater poverty to have higher birth rates. Yeah, so I think one of the GDP. So if we were to compare gross domestic product of the country to the birth rates, we might find that they have lower gross domestic product than other countries. And I'm going to make a note to look at that next week. Next week, we're going to compare two quantitative data sets in other ways. So birth rates versus GDP. That sounds interesting. Thank you for that observation. You guys rock. All right, so let's see, what can we say about this based on the summary statistics and the histogram? The birth rates distribution has a skew to the right. And we can see that in the graph. And again, we might mention the mean is higher than the median. So as shown in the graph, frequency histogram is the more technical name for that. Just call it histogram. Mean is greater than the median, which we usually see in a skew right. That's our evidence. There are several countries. How many? 1, 2, 3, 4, 5, 6, 7, 8 of them. So 8 out of the 202 countries have unusually high birth rates compared to the rest. Other comments I could make is that a large majority of the data looks like it's within 1 standard deviation of the mean. We didn't calculate that. For some data sets, it ranges from like 50% to 70% will be within 1 standard deviation. That's not as clear cut as the 95% rule, the 2 standard deviations. So I've just made a couple of observations about what these numbers are telling me and what the graph shows me. So if I was reporting this out somewhere, like in the news or conversation with my mom, if I just told her like, hey, this is the histogram, here's the mean, here's the standard deviation, she's gonna be like, what? But if I said, hey, these are some interesting things I've observed about some countries, and I went over and talked about there's several countries who are unusually high compared to the rest. And she'd be like, well, how do you know that? And then I could get into some details about how I know that here. All right, let's try this on another data set. How about, let's see, death rate or life expectancy? Let's go with death rate. So I'm just gonna, I already have that in here from a previous class, but we're just gonna start over. It's nice to know which country is which, so I'm going to grab the countries. New tab. And then I want to grab their death rates. There we go. Copy, new tab. And then, since I have these calculations already ready to go, I wonder if these will work. Should work too. I should be able to highlight all of these and put them in that other spreadsheet, and they should just work. Not sure about those last 3 calculations though, but maybe. That looks good. Looks good. That's not good because they're not ordered. Okay, so next thing I'm going to do is I'm going to set them in order. So highlight them or use the quick keystrokes. Data, sort range, has a header row, this time by death rate. Smaller ones at the top. Okay, and then let's make a histogram of just the death rates and decide on how to group. Okay, so Google chose to jump by about 1 each time. So cleaning that up, customize histogram. Instead of auto, I could type a 1, starting at 1.5. If we want to start at a different point, you go down to the horizontal axis and pick a new minimum. Like maybe we want to start at 1 instead. Okay, standard deviation is almost 3, mean is almost 8. So let's see what 3 looks like for the histogram bucket size. That looks like too few, doesn't it? I think the 1 was okay. What does 2 look like? So again, there is no best histogram. You got to play around a little bit and find something that you find visually appealing and maybe has some other good characteristics. You know, that's not too bad either. I think I like this one. What was the other one I had? 1. And sometimes I'll make more than 1 and set them side by side and then say, oh, I think I need both of them for this. So often I'll make 1 histogram and then just to compare with others, because sometimes I can't remember what each look like because I looked at a bunch, I'll just make another histogram. Let's just move this down a little. Okay, and just for comparison, what was the other one I said? I thought 2 looked good, starting at 1. What do you think? Bucket of 1 or bucket of 2? Somebody vote for me. All right, I got to vote for 1. Let's go for it. Okay, so I should fix the titles. And death rate, like the birth rate, is going to be out of 1,000 people. And then we should indicate what that column means over there. So that's vertical. And what are we counting? Frequency is a count. We're counting number of countries. Cool. All right. And so draw a rough sketch of that on a piece of paper, labeled at the bottom, equally spaced 1, 2, 3, 4, 5, and so on. Take a screenshot. And then we just play around with that. Oop, wrong button. 95% rule. What do we got? We have a mean. What do I want to call those? Easy numbers would be to call them 8 and 3. I guess that's good enough, sure. So we're just eyeballing it. So I'm going to say that X bar, the mean, is about 8, and that S, the standard deviation, is about 3. So if I make that count by standard deviations down here, z-scores, we would put 8 in the middle, so that'd be a z-score of 0, and then counting by 3 from that, 9, 10, 11 would be a z-score of about 1, 12, 13, 14 would be a z-score of about 2. Going the other way, 1, 2, 3, 5 would be about 5 deaths per 1,000, would be about -1, and then 2 would be about -2 for the z-score. So according to the 95% rule, we should expect to see about 95% of countries fall in this region right here, and that looks pretty sure. Remember to identify that exact number, I'm calling it about 14, on the spreadsheet, I would say, hey, what's X bar plus 2 standard deviations? Oops. And what's X bar minus 2S? And I already have those calculations in here. About 2 and then about 13. And the computer says there's about 96 of them in there. And that is incorrect. So the way I built that formula didn't work. It was very specific to the numbers on the other sheet. There is a way to make the computer count that automatically, but it's not easy. So I'm not going to go over that here. I'm just going to actually look. So 2.34 up to 13.02. So equals count. I'm just going to drag across those. That would be here up to 13.04-ish. So about 13.3 is as high as I can go. Out of the sample size, which is the number of countries that reported or we have recorded for a birth rate. And in this case, it's 202 again, interesting. And we get about 96%, kind of like before with the birth rates. This is for the death rates. Yeah, so 95% rule, again, I said it's about 95% of the data value should be within 2 standard deviations. I'm just verifying that 95% rule just for fun. But this does allow me to find outliers. So a country would have an unusually low death rate if it's less than 2.34. So these 2 countries right here have unusually low death rates. So let's make those green. It's good to have a low death rate, I think. Qatar, United Arab Emirates, those are very rich countries. And then after the 13, they have very high death rates compared to everybody else. So that would be these countries right here. Let's make those red. More likely to die in that country than in other ones. So notes, what can we say here? So countries in this region right here, right? These are outliers. This is the usual 95%. And these are outliers too. These are unusually high. So things I could say about this distribution, that's relatively symmetric. I don't really see a clear tail there. We could compare the mean and the median in terms of identifying skewness, but I don't really see it. Let's see, what do we got? The median is 7.2. The mean is a little bit higher. So according to that, maybe it's got a slight right tail, but a different histogram, it might be hard to identify that. So like every histogram looks a little bit different based on the decisions you make for where to start and how big each group is. So yeah, I guess there's a slight right skew, but it's not all that clear to me. So I'm just going to say this distribution is relatively symmetric and bell-shaped. You could say maybe there's a slight skew right. Maybe you see a tail more than I do. You could use the reference to the mean and the median to identify that. I'm not going to here because it's pretty slim in my opinion. And then I can mention the idea of outliers here. So there are a couple of countries with unusually low death rates compared to the others. And let's see, there were quite a few more. So what's that about? 4, maybe 5 of them 2, 3, 4, 5, 6 of them. 6 with unusually high death rates. Okay, so we're going to tack a little bit more onto this. We're going to include the 5-number summary here. To do a 5-number summary, you need the 5 numbers. So we've got those.